Prabhakaran, are you?
Yes, sir.
Prabhakaran, are you ready? Prabhakaran?
Yes, sir. I'm connecting my phone now, sir.
Okay. Prabhakaran, are you ready? Prabhakaran?
Yes, sir. I'm connecting my phone.
Okay. Once you are ready, Prabhakaran, we will start the session. We are ready from here. Dr. Naveen also available.
Yes, sir.
Yeah.
Yes, sir.
Yeah.
Sorry for the delay, sir.
Okay.
A very good,
Not
a
an
very good
issue.
morning. Yes,
Yeah. Good morning, everyone. This is Ashok Kumar from CMTA. I welcome everyone for this wonderful session on infrastructure lecture series what we are conducting in past 6 months. November we have started, and this is our 14th webinar in this series. Today with us, Dr. Naveen. I have invited him to speak on shallow foundations, and Dr. Naveen is a wonderful speaker from Amity University. I welcome Dr. Naveen for this wonderful program, sir.
Thank you.
And Mr. Prabhakaran, my colleague, is going to introduce Dr. Naveen's profile to the audience. Post that we can start the session. Over to Prabhakaran.
yes, sir. A very good morning to one and all present here. Myself, Prabhakaran. I'm here to introduce the speaker, Dr. Naveen BP today. Now, Dr. Naveen BP is an IEI recognized chartered civil engineer, expertise in geotechnical and geo-environmental engineering. He did his bachelor in civil engineering at University Visvesvaraya College of Engineering, MTech in geotech engineering at NIT Karnataka, and accomplished his PhD and masters at Indian Institute of Science, Bangalore. He is currently the associate professor and head at Amity University. Also, his past experiences include senior geotechnical engineer, senior research associate, and senior design engineer. His fundamental interest and expertise lie in research in geotechnical and geo-environmental engineering, which includes ground improvement techniques, deep foundation, environmental impact assessment, solid waste management, water and leachate analysis, underground infrastructure, etc. He was recognized with several awards such as Young Geotechnical Engineer, IAI Young Engineer Award, Young Educator and Scholar Award, and many more. We are pleased to have you today with us, sir. And now the platform is yours. Thank you, sir.
Thank you, Prabhakaran. Thanks for the introduction. First of all, I would like to heartfelt thanks to Ashok for organizing the webinar series for undergraduate and postgraduate students. First of all, I'm hats off to you, sir. You have taken this program very seriously and you are doing from past 6 months. And every time you are identifying some burning issues in the civil engineering and you are requesting speaker to discuss specially on what is the basic needs for the UG people when they are going for interview or who is going to take a all India exams. You are just giving a at last moment they can recall or they can brush up their basics. So keeping in that perspective, you are organizing the webinar series, and also you are requesting us to prepare this slide such a way that even non-technical students should able to understand. So keeping your points, and I developed the presentation, and today I'm going to deliver a talk especially on shallow foundation. In our previous lecture, I discussed about the deep foundation. Today we are trying to understand why shallow foundation plays an important role. And before that, we should understand why foundation plays an important role in geotechnical engineering. This you can see the clear picture. This is at shallow depth, that's why it is coming, and you're putting the foundation, this is put. But if you are understanding in the perspective of engineering with a definition or a formula, in coming slide, I will be showing that why, what, when you have to use all this. So first of all, my presentation goes in 7 steps. First is introduction, then followed by the classification of foundation. In introduction, I'm just going throwing some light on what do you mean by foundation. Before going to shallow foundation, first we have to understand what is the meaning of shallow as well as foundation. Then after understanding, we are trying to classify of the foundations. Then we are going to discuss on choice of foundations. We have several types, but what all the types will be there? There we are going to understand, and also why foundation plays a major role in any structure. If you are not doing, what all the disaster may happen. For that, we have to understand the settlement of foundation plays a important role, and also the types of shallow foundations. There you will be seeing 6 types of shallow foundation. After understanding it, like to make you feel of the subject, that's why I've taken on generally case study type. This is in a general black cotton soil. In this type of problematic soil, how shallow foundation can play important role. Generally, when black cotton soil comes, we go for a deep foundations like underim pile. In case if you are going with a shallow, what is the procedure? What are the precautions you should take when you are construction? So to make you complete from definition to final application, keeping in that point and developed my presentation. So now we are starting with the definition called what is foundation. If you are asking foundation, this question may be coming in your examination or in interview, they will ask. So the foundation can be discussed in a 2 perspective. One is structural point of view as well as geotechnical point of view. You can see this this arrow mark. This is all loads. The foundation is an element of a structure that takes load and distributes it safely through the soil. That is called, see, this is the load they are taking and safely they are transferring to the soil. See, this is the point load individually, how it is distributing in, this is the elements. You can see, this is the structural point of view, person will only concentrate on this. But if you are seeing the geotechnical perspective, the foundation is also the surrounding soil, or this load, whatever the transferring, it should be taken care by the soil or rock. See, this is the, when this load is transferring to the soil, see how the load is distributed. That's why if soil is at good, we will go for a shallow depth. If soil is at weak, this much load, if soil is not able to take, then we are going for a deep foundation. In last series, we have understood when, what types of foundation, procedure, everything. So similar line, today we are trying to learn about or discuss about shallow related. You can see without foundation, the force will distribute into small area of the column. It means that if in case you may ask why I want to provide foundation, without that I can construct. In case if you are doing that, that load which you are transferring is only small area. So to avoid this, in case if you introduce the foundation like this, see this load is equally distributed. You can see this without foundation, how this load is transferred only to the small area. That's why ultimate is called load by area. And the foundation spreads the load into larger area, which reduce the pressure imposed on the soil underneath. See this load, this is the load, this is the column load transferred to the foundation. It is equally distributed. You can see this. And this pressure must be always less than the allowable bearing pressure. When you're designing or anything, it should be always less than allowable. See, this condition should satisfy. Q equals, this is the column load plus weight of the column plus weight of the footing divided by area less than or equal to allowable capacity. See, this is the thing you have to keep on concentrating when you're doing the shallow foundation. And also, when you're designing a foundation, you should consider basic things like a self weight of the foundation, which include weight of the concrete and soil above it. See, the weight of the soil, weight of the column, this, and also the weight of the column under the soil must be considered. See, this is the, when you are designing, you should consider all this. And now coming to the settlement of the foundation. Suppose if you are not understanding the nature of the soil, whether this load, whatever the structural load is coming, if that load is able to take care at the shallow depth, you can go. Otherwise, if it is, you are going for a deep, we know that. But in case if you are not following, just randomly you are without understanding the nature of the soil, just if you are constructing, then there will be a settlement take place, that is in the form of even settlement. If soil is an uniform, then even settlement. You can see this is the natural ground level, how it is got the undulation, you can see. If it is a loose pocket, it can go for a differential settlement. So if you understand the soil and if you design the foundation, you can resist from the settlement. That's why good foundation will always prevent or reduce the effect of all type of settlement. So it will not be harmful to the structure. See, this is, if even settlement, it will settle equally. Differential settlement, some soil, it will be weak here, strong here. It will become imbalance. This is called differential settlement. See, if you are providing foundation, what you will be overcoming? It will prevent from the settlement. See, this is the differential settlement. This is the natural ground, the soil, how it is going below, you can see. And also it protects the structural against soil movement, protect the structural against lateral soil movement. You can see the soil pressure, how it is happening below the ground. And also allow building over water or waterlogging ground. Provide the support against uplift or overturning and wind. Act as a support to the structure. See, the importance of constructing foundation is this 6 criteria. And also, engineers should design the foundation to satisfy the following conditions, like ultimate is less than or equal to allowable load, and the total settlement is always less than allowable. This is the differential settlement is less than or equal to total settlement of allowable differential settlement. See, this condition should be satisfied before going to complete the design of foundation. Otherwise, settlement will take place. And you can see if it is a differential settlement, it will take like this. The cracks will be developing. This is a uniform settlement. It is just going below. Now, we have understood the foundation definition and the importance of the foundations, what all the criteria we have to fulfill, why you want to do. Now, before making the choice of foundation, why you want to do, how you will be doing. The goal of design to determine the foundation is based on the size, type, and depth of the foundation. The engineer must select the suitable type of foundation depending upon the several factors. Suppose if I am suggesting isolated footing or if a width of like 10 meters or a 2 meters or a depth, on what basis I will fix that? How can I say it is a shallow or what? So always this will be decided based on the several factors like nature of the subsoil, clay soil, sandy, gravel, or soil strength for parameters. So that's why we used to do the bore log. We try to understand each layer very effectively, whether that much load is coming. If soil is good and the load is less, then the dimension of the footing also will reduce. And if that much load is able to take at shallow depth by increasing foundation, then you can do by trial and error. That's why they told that you can be done by playing the size or type of the depth. If soil is good, then only you can able to do. If soil is not good at shallow, then there is no option. You have to go for the deep. And next factor is material. like in situ concrete or precast concrete or steel. What type of foundation? Again, that is depend. And also economical consideration. Shallow foundations are cheaper than deep foundation. Yes, this condition will apply only the soil are good at shallow depth, then only. Layout of the structure, building or floor plan, positioning, load, etc. Condition side. See, again, whatever we are doing, end of the day, we have to see the site constraint also. The like a size of the footing, maybe combined footing or isolated footing, everything that will be decided based on the site condition. As a civil engineering, your primary duty is to visit the site, understand these factors, what all, then you have to design the foundation accordingly. Next thing is, mainly when we are designing a foundation, we require shear strength parameter, that is cohesion and friction, that we can be done by doing triaxial test. In the triaxial, we have three types: UU condition, CU condition, CD condition. So UU means unconsolidated, undrained. It will be like a very fast. If you want to check immediate, then you will be going. And consolidated, undrained test. And if you want to understand long term, then you have to go for a consolidated drain test and direct shear test as well as range shear. If you do all these 5 tests, you will be getting strength parameter like cohesion and friction. And also for designing the foundation, the primary factor will plays a major role, like subsurface. If you are talking about subsurface, means the Borlaug report, always we should have a unit weight with respect to layer. And also where the foundation is coming, you have to take that soil sample, conduct the Yeboah experiment, and take the shear strength parameter like C and 5 values. Even after understanding, you should understand groundwater table, at what level it is coming. Then structural requirement. This all will come under primary factors. And coming to the secondary factors, while selecting the foundations are construction axis, the method and site condition. Means if you may be suggesting something. For example, if I'm talking last webinar, I was telling we may have some budget, but if I want to mobilize a rotary rig, I can't do because site constraint. Then you have to go for a manual method like a winch method. So if you have money, you will introduce a new means, it can't be done. Always the method, mobilization of material or design of foundation, it should be done based on the site condition only. It will be decided. So that's why I was telling you from in my class, always civil engineering should visit the site, understand the nature of the site. Then you have to do this basic exercise, and you are the person, you will be giving the guidance to the person like okay, this method we can't apply, so this is the very simple method we have to go for. This is all you will be deciding when you do the recognized survey. So based on that only you will decide the construction procedure and also what are the environmental factors, and also you will decide the building code and regulations, impact on surrounding structures when you are constructing, how it will impact, like when you are drilling, that vibration will disturb the adjacent building. So this all you have to take care. Then to arrest that vibration, what could be the alternative method? That everything you will be decided when you go to the site, whether you have a sufficient place, what all the things, and also the construction schedule, and so construction risk when you are doing, when you are excavating or something, adjacent building may collapse. So for that, you have to understand the site scenario first. Then only you will decide the type of foundation, and also you will understanding the main thing is soil report. In the soil report, always you should concentrate mainly on the shear strength parameters and unit weight and water table. Now we are coming to classification of foundations. Foundation can be classified into two types. One is shallow foundation as well as deep foundation. As I already told you, if soil is able to take the required load of structural at shallow, when we will be going for a shallow like this. If soil is not able to take at shallow, then you have to go for a deep foundation. In foundation also you have classification like shallow as well as deep. In shallow you have again 4 types: pad foundation, combined foundation, strip foundation, mat. Sometimes they will call as a raft also. You can see this is also isolated footing. This is a combined. This is a strip footing, mat footing. In this presentation, individually we are trying to understand when to use all the details in detail. And deep foundation, again deep foundation can be classified as compensated foundation, pile foundation, pier foundation, caissons foundation. This we have discussed in the last series. So now our talk is restricted only for the shallow. Now, if I am talking about shallow, means the definition when the depth of foundation is equal to, see, this is the D and the B. If depth of the foundation is equal or less than the width of foundation, then it is termed as a shallow. And it is also known as an open foundation. We can call this as a shallow as well as open foundation. The shallow foundation is placed immediately below the lowest part of the superstructure. See, this is the, if soil is good, you will be just lowering that. This is the pressure distribution. This is the column load transferring. And also the footing is the foundation unit constructed by the brickwork, stone masonry or concrete. You can construct this footing by brick or stone masonry or concrete below the base of the wall or column for the purpose of distributing the structural load over the wide area. See, this is the wall or a column. This is the shallow, this is the deep. If it is more than 3, that's why D by B, if it is greater than or equal to 3, this concept they are trying to say. Again, we have types of shallow foundations like spread footing, combined footing, strap footing, mat, or also we can call as a raft foundation. We will try to understand individually now. Spread footing is nothing but the footings are those which spreads the superimposed load of wall or a column over a larger area. The spread footing, either a column or a wall. The spread footing, again, it can be classified as a single footing, that is called isolated, or step footing, or a slope. It in the form of trapezoidal shape will be there, that we can call as a slope footing or a column, and wall footing without step, and step footing for a wall, and grillage footings. Now we are trying to understand which condition we are using. This is the isolated footing, or we can go with you can call as a pad footing in a different. This is in a tripodal shape, rectangular, circular. In this case, the footing may consist of simple concrete block projection out of column face on all the sides. This is the, you can see it's projected all the faces, and the base of the dimension of the concrete base should not be less than the twice of the appropriate lateral dimension of the column in that direction. See, this is the criteria you have to fulfill when you are doing for this. And the thickness of the concrete block should at least be equal to side of offset from the column face. This is the offset, you can see, you have to. So when you are doing, you have to be taken care. And also the step footing for the column, if the column is more, or if the shape bearing pressure of the soil is less, then the base area will be large. In such cases, it is necessary to provide masonry offset to achieve the larger spread before the load is transferred to the concrete base. Here, the height and width of each should be proportional to the rate of spread, doesn't exceed the permissible value of the masonry. So this is. Next is slope. I told you slope is nothing but trapezoidal shape. This is also known as an isolated or an individual column. They have their projection in the concrete base. So you can see that picture. This is this, which I'm talking individually. This is the projection. This also coming under isolated, but the shape is in trapezoidal. Due to the low bending strength, the footing constructed with brick or a stone or a plain concrete required considerable depth to the safe to carry the heavy load. And also the depth of plain concrete footing can be reduced much by providing a reinforcement at the base to take up the tensile stresses. RCC column footing may be circular, rectangular, square, in plane. Its shape can be anything. See, this is concrete base. You can see this is the stepwise. This is the trapezoidal, which I told you isolated. You can call as a pad footing also. This is the plan of that. If you see, you can see like this. This is in a front elevation. This is the plan of each. For this, you can see the shape, how it is. Now we are coming for strip footing. Here we provide a continuous longitudinal bearing. Thus the spread of the continuous wall is called strip footing. This is the wall. The load is transferred uniformly here. When the wall carries a light load and the safe bearing pressure is very high, the width of footing may be very small. In such cases, wall directly rests on the concrete base and no masonry offsets are provided. In this case, see, this is. And now this, which I was talking, is a continuous strip footing. Now this is a step footing for a wall. When wall carries heavy load and the safe bearing pressure of the soil is not very high, then the base width required may be much greater. You can see this. This is step, how it is. How the steps are decided, they are trying to explain by this paragraph. In such cases, we can use for masonry offset or provided to the achieve larger spread before load is transferred to the concrete base. And also in the case of typical wall footing, the lower course of the brick will have the twice width of the wall above the plinth. The base of the wall is achieved by providing 5 centimeter off. This is the 5 centimeter offset you are giving from year to year always. That's why you are going stepwise on the both side of the wall. And also the depth course may be 10 to 20 centimeter. See here, it may be 10 to 20 centimeter. It will be varied. This all general guidelines. Next, grillage foundation. Again, you have two types of in this, steel as well as timber. Grillage foundation is also, I told it is coming under isolated footing. We are providing grillage foundation when the heavy structural load from the column or pier or steel are required to be transferred to a soil, when they're having a low or when they have a poor or low bearing capacity. In that condition only we will be using this. Again, this foundation can be divided into steel or timber. In steel, what it will it is consisting of steel joints or a beam, and also which are provided in a single or double tiers. And also the maximum cover of 10 centimeter is kept on outer side of external beams as well as above upper flanges of the top tier. And the depth of the concrete below the lower tier should be at least 15 centimeter. See, this is the plan. Now you can see this, which I was telling. This is the iron plate column, which they are telling 5 centimeter. This, when you are suggesting that conditions should be fulfilled. This is the concrete pad and this is the steel beam. This is the iron plate. This is the steel column. Similarly, we can do for the timber also. The timber type foundation we are providing when the heavy loaded of the masonry wall or a timber columns. This foundation specially used in waterlogged areas only. This condition when arises, then we are recommending the timber. Where the bearing capacity of soil is very low and where the loading of soil is limited to 50 to 60 kilonewton per meter square. And the foundation uses is timber plank or a timber beam in place of steel. That's why we are calling timber. We are not using steel, and no concrete is embedded between the timber joint. However, the bottom concrete provided in the steel grillage foundation is replaced by timber platform constructed of timber. So it is completely, see, this is the timber. This is the section. This is the plan. This is the wooden beams. You can see this is the planks. If you take a section, it looks like this. What is the dimension? To understand, they are mentioning the typical timber grillage foundation for the timber column. Excavation of the base is leveled first. Then the bottom layer of the timber flank size is 20 to 30 centimeter. And the wide is 5 to 7.5 centimeter thick, laid by side to side without any gap between them. And also over the top of the layer, the timber beam of the same section as that the wooden post is placed. That's why they are trying to say, you can see this wooden, and this is the planks with a 20 to 30 centimeter plank they are using. That width is 5 to 7.5 centimeter. Thickness will be there, this wooden plank. This is timber grillage for footing. And another layer of plank against laid is laid at the right angle to the direction of the beam. The upper layer of the plank may be 7.5 to 10 centimeter. The thick extended over the full width of the wall, base over the mason. See, this is the thing they are trying to say. This is, see, offset is 45 to 60 centimeter, and this thickness of the plank will be 8 to 10 centimeter. And this will be in the rectangular section, 40 centimeter, center to center. And this is combined footing. Combined footing is nothing but two individual footing we are combining. Combined footing is a single footing with support by two columns. And it is provided under following situation. When the columns are near to each other so that their footing will overlap. Instead of this, combined footing will be recommended only for the following conditions. When the columns are very near to each other, see, these two columns are very near so each other so that their footings are overlapping, then we are going for a combine like in one. And also when the bearing capacity of soil is less, required more area under individual footing, then we are going. And also when the end column is near to a property line, so the footing cannot spread in that direction. In this condition, we are recommending combined footing. That's why I told you type of foundation again will be decided based on the site condition. This all will come to know when you visit the site. Just taking soil report and designing, you can't do this. In combined footing, you have three types. Rectangular footing will be there, trapezoidal will be there, combined wall footing. Rectangular footing means the combined footing will provide a rectangular in shape if columns are carry equally load. Then we are going for a rectangular. The design of rectangular combined footing should be done in such a way that the center of gravity of column coincide with the center of footing. And also the trapezoidal combined footing will be done if the column carry unequal loads of the footing. Then we are considering the trapezoid. It clearly shows that type of the loading will decide the type of the loading, and soil condition will decide the shape of the footing also. If it may require provided a combined footing for a column and wall in this column wall footing. See, this is the rectangular. If it is a load is equal, then you will be going. If it is a load is unequal, then you will be going. But your center of gravity, it should coincide. See, this is the adjacent property wall. That case 1, case 2, which I was telling, that is the thing. And the strap footing. Strap footing means it consisting of two or more footing of individual column by beam. Means two footing that is connected by the beam. That is called strap footing. Strap beam connecting the spread the load of the two columns doesn't remains the contact with soil and thus doesn't transfer any pressure to the soil. This beam won't transfer any load to the soil. Just it is a connectivity only. The function of strap beam is to transfer the load of heavy loaded outer column to inner column. In doing so, the strap beam is subjected to bending moment and shear force, and it should be designed to withstand this. The object of introducing the beam is to transfer the load to heavy loaded outer column only. See, this is the thing. This is the two individual footing connected with a strap. When you see, this is the elevation, this is the plan. This is the strap footing with adjoining the wall. This is the plan, this is the elevation. Now coming to raft foundation. Raft foundation is a combined footing that covers the entire area beneath this structure and support all the walls and columns. When the allowable soil pressure is low or building loads are heavy, the use of spread footing would cover more than one half of the area and may prove more economical to use mat or raft foundation. You will be using raft foundation only when soil pressure is low or the building loads are too heavy. In that case, only you will be recommending. Otherwise, this foundation is not economical. The mat or raft foundation tends to bridge over the erratic deposit and eliminates the differential settlement. Raft foundation is also used to reduce the settlement above highly compressible soil. See, in raft also we will have three types. Again, solid slab system, beam slab system, cellular system. All the three types are basically the same, but consisting of large, generally unbroken areas of slab covering the whole or large part of the structure. Let me see the picture. See, this is the thing. The soil pressure will be less, the soil, or it is coming huge building load. Then only we will be recommending. See, this is the entire area there. This is the construction of mat. Generally, very rare condition they will go. Otherwise, see, you can see this is in a raft. Where the building loads are very heavy, then only we are going for this condition. Now, till now we have understood the types of foundation and that guidelines. Now, after understanding the different types of foundations, now we want to understand if soil is good and load is coming, then you are able to decide at shallow depth, and also based on the site constraint, you have decided the shape also. But if soil is only problematic soil, in that condition, what you will do? Like problematic soil means that is black cotton soil, because it have a shrinkage and swelling behavior. So if you are encountering that type of soil, then what you will do? And the construction of building on black cotton soil or expensive soil is very much dangerous due to its volumetric change with the change of atmospheric condition. We told with respect to climatic condition, the behavior of soil will also keep on changing in black cotton. That's why we used to call as a problematic. The differential settlement of building costs, because in problematic soil, the settlement will be always differential only. So the differential settlement of buildings caused by the movement of ground due to the alternate swelling and shrinking. And this will result in the formation of cracks, thus formed and sometimes of 15 to 20 meter wide and 2.5 to 4 meter deep. In one of my slide, I showed you when we are advantages of introducing the foundation. In that picture, I showed you the differential settlement will happen, the cracks will develop. That will be, the crack will be 15 to 20 centimeter wide, which will be there, and also the depth will be 4 meter deep. So how precautions for the foundation in black cotton soil, how you will take the measure? First of all, you should take to such a depth where the crack ceases to the extent. You should understand the soil where it is good. You have to go till that level. The minimum depth of the foundation, at least you have to maintain 1.5 meter. The construction in black cotton soil should be carried out in dry season only, not in rainy season. I told you it is in a very, it will change according to its condition. And also the external wall should be provided with plinth protection at the ground level, so that moisture doesn't enter into foundation during monsoon. The object of introducing the plinth is so moisture won't transfer to the foundation. In case if it is happening, it will happen uniform settlement, not differential settlement. That is also one of the reason where the soil occurs only in the top layer, and where the thickness of the layer doesn't exceed 1 to 1.5 meter. The entire layer of black cotton soil should be removed. I told you, if you found that, you have to completely remove that, fill with a good soil, good clay, and foundation should be laid on non-shrinkable, non-expensive. That is called as a clay material with a good soil, with proper compaction. And where the soil is highly expansive, it is very essential to have a minimum contact between soil and the footing. If you found that is then you have to isolate from that. This can be achieved by transmitting the load through a deeper piles. That's why I told technique. So the type of foundation generally for black cotton soil, we will be going for a strip or a pad foundation. If it is soil, black atom soil, it is shallow, if we can remove and go, then we will go for a strip or a pad foundation, or pier foundations, or under-rim pile foundation. I already discussed under-rim pile foundation thing in last class also. Now also just I will be showing some glimpse. And strip or pad foundation, both are same. For a wall and a pad foundation for a column may be provided for a medium loads. When the soil is soft and having a poor bearing capacity, a 30 centimeter thick layer of ballast and moram should be provided and rammed, and then 30 centimeter thick layer of coarse sand may be placed. See, this is the guideline you have to follow if it is you're doing at the shallow depth, if you are introducing the strip footing in the black atom soil. And also the 60 centimeter thick layer of cohesion-less soil, if it is placed, first you are placing, you can see first you are placing ballast and moram should be provided, and then you are ramming, then 30 centimeter thick layer of coarse sand may be placed. See, this is the procedure you have to follow. Then you will be introducing 60 centimeter thick layer of cohesion-less sand is placed below the foundation concrete and is compacted. Then sand is also filled around the footing. When the soil swells, the sand grains would yield by moving up, thus relieving the swelling pressure. See, this is the, if it is swelling is happen, this will be overcome by the sand. That's why we are introducing the sand. And also when the soil shrink, the sand layer would expand, but there will be no discontinuity in the soil support. Sand fill should be used below the flooring. See, there are two types in construction. One is by using sand fill structure, which we have understood the procedure. And also the second thing we can do by alternative layer of sand and more. This is the tricky thing. We can use that permutation combination in the site condition based on that. Alone sand can be done, or we can use one layer of moram also. So for that procedure will be like this. It will be suitable where swelling pressures are relatively high. The alternative layer of moram and the sand act as a spring. When you are introducing, it will be this moram and the sand will be always acting like a spring which can compress or expand along the subsoil movement. So also thus it will absorb all the movements and keeping the footing free from this effect. If the soil is soft and has poor bearing capacity, then the 30 centimeter layer of ballast and moram should first be rammed into the soil. See, you have to understand and you have to introduce the material according to the site condition. And also over the top of it, the minimum 30 centimeter of thick layer of coarse grained sand may be placed. In all the three cases, the foundation concrete may be done in rigid cement concrete, and if possible, it may contain nominal reinforcement. See, this all you're taking extra measures to avoid the settlement. That's why you are following all these guidelines. Next, it coming to pier foundations. For the walls carrying heavy load, the pier foundation with arch may be provided. And also the piers are dug at the regular interval and filled with a concrete which will be connected by the concrete or masonry arch, and the wall may be constructed over it. See, the arch are constructed with a gap above the ground level, which may permit the movement of soil during the swelling and shrinking operation. See, this is the picture of that. This is the hard soil. This is the concrete pier, which I was telling the arch. This is the wall. This will be. This is the L section, and this is the cross section of this. Now, finally, the D foundation concept is under-rim pile foundation. Under-rim pile foundation always we use for clay soil or black cotton soil only. If load is heavy, then we are using 2 bulb. If load is less, then we can go with a single bulb. Again, this will be dependent upon the soil condition also. See, piles are commonly recommended for providing safe and economical foundation in expensive soil, such as black cotton soil, having a poor bearing capacity. In this type of foundation, the structure is anchored to the ground at the depth where the ground movement due to the changes in the moisture content is negligible. And also the pile having one bulb is known as a single bulb. I already told you. And it's seen that the load bearing capacity of the pile can be increased by increasing the number of bulb. If you want to increase the load, then you have to increase like a 2 bulb, 3 bulb also done. But the guideline should be followed when you are constructing. That procedure I told you, by drilling, first borehole, cleaning the borehole, then lowering the reinforcement. That when you are drilling only, you will be using, you can't drill like normal pile. For that underrim pile, the equipment is completely different. When you're drilling, when you are putting that equipment, the bulb will be created at every 1.5 meter. So that, see the method construction, this is the thing. When you are drilling, this bulb will be created. This bulb will be created when you are doing boring only. After doing boring, you will be cleaning the borehole, reinforcement will be poured, reinforcement will be introduced, then concrete will be poured. This color is concrete. And you can see this. Here they are going 2 bulb because the load coming in this grid is too high. That's why. On top of that, they have connected with a pile cap. This is called single underrim pile, and this is called double. We can go for 3 bulb also. Again, this will be dependent upon the load, structural load. This is the finished floor level. This is the pile cap. See, edges they have done with a single pile, single bulb in center, because in center the load is coming high. The procedure is same. The design will be same. Only thing, when you are construction, you have to maintain for 1 bulb to 1 bulb, at least you have to maintain 1.2 to 1.5 D from difference of this. This is the internal dia, this is the bulb outer dia. Thank you.
Thank you, sir.
Thank you.
Audience, if you have any questions, you can ask. The program was very much informative. Sir has given a brief idea about the shallow foundation, the basic definitions he has provided, and with the pictures he has quoted very much nicely. And sir, there is one question from audience, Swami. Sir, what is the measurement unit of D?
In the first definition, I already told. See the deep word when you are D. What is the measurement unit of D? It may be centimeter or a meter only unit. I was thinking he is asking a depth. No, depth will be always will be centimeter or in meter only.
Sir, hello sir, myself Vijay.
Yes.
Sir, where pile foundation is sir used? I just didn't listen that you explaining.
Yes, yes. See, simple thing I showed you in the first thing only. Pile foundation can be used in 2 situations. Pile can be used where you can't, like a soil, you are coming a huge load, you have a load should be transferred to the soil at greater depth. Suppose if you are getting a 10 tons, if soil is not able to take the 10 tons at shallow depth, then you will be going for a deep foundation. Then the deep foundation will come. When you are going for a deep, generally we will go for a pile because that is a very economical foundation. Because pile we are referring, it is like you can complete the work in very fast. Suppose if you are going for a bigger foundation, the time will be more, the cost will be more. The pile will be always like economical way, and that will be again the depth will be decided based on the soil condition. If soil is at good, you may restrict at 5 meters, 6. Like one of the example is underrim pile. Generally, underrim pile will be 6 meter depth only. If 2 bulb is going, then it will be 8 meter. That's why I told you, if soil is good or a load will be very high, then that's why I told, in that condition only it will. But you are asking the deep foundation thing. If you watch the deep foundation video, you will understand different types of pile. Which I was talking is a generalized pile. if you see a different types of pile, and that procedure will be completely different. Again, this will be decided based on the site condition. You may have a rotary method, you have a winch method. Suppose when you're doing a boring, borehole will start collapsing or somewhere seepage is happening. So these are the challenges. At shallow, you can visualize because that is in a shallow depth, you are completely excavating, which I showed you for a raft foundation. You are
Yes, sir. Yes,
completely
sir.
excavated. You know that what is happening in the foundation, how you are constructing. But deep, nothing. You are just doing like a postmortem. You are just drilling, you are putting the reinforcement, putting the concrete. But you should ensure that, yes, my foundation is very strong. How? That we have some thumb rule. By practical, you will get that knowledge. So suppose
Yes,
if
sir.
10 meter ton, 10 meter depth, you will be calculating the volume for the 10 meter. It may come like 5 meter cube concrete you have ordered. But when you're doing, it may consume 7 or a 6, or it may less. Why? What would be the reason? How? When you do the calculation, it should come approximately same only. It means that in that time, when you're drilling, borehole is stable. Somewhere the seepage is happening, or borehole got collapsed when you are doing the concrete or reinforcement lowering. So that you can't able to visualize when you're doing a manual thing. That's why we need an expertise, experienced person in the field, especially when you're doing manual boring or manual piling. And now to overcome all this, and we have a time constraint to complete the project, we are now utilizing the mobilizing, especially rotary rig instead of going manual. That's why in Metro Foundation, always you will see the rotary rig. The beauty of rotary rig, it will clearly identify where the what depth water table comes, even type of soil also you can visualize when the soil is coming out. And also if borehole is getting collapsed, the sensor will detect. Based on that, you can take the immediate call, like introduce the bentonite or putting the casing. So when you are ordering the concrete, you will be confident. But when you are doing a manual, you won't have confidence. But in shallow, you won't have that risk. Only thing, you have to understand the nature of the soil because you are excavating and doing, whether it is in a combined footing or a single footing, any footing, that is like a open. But in deep, I told, it is like a, again, all the, it will be like
Okay,
below
sir.
ground level.
Okay, sir. Okay, sir. Thank you so much, sir, during the talk, sir. Listen, sir. Extremely
sir,
humble, sir. Okay, sir.
Naveen sir,
Yes.
thank you for your detailed explanation.
I was thinking some
It's,
student is talking. I was
Yeah.
not.
yes, sir. Yes, sir. It's beautifully explained by sir, sir. Thank you, sir.
Thank you. And I request you, you please see the previous series of the
Deep foundation.
T Foundation. So
Yes, sir. I sir logged in, but I didn't get the connectivity, sir. That's why the poor connectivity I didn't get was the attend the
That is
seminar.
still, I will explain you that the video is still available in YouTube. You can watch anytime.
Oh, yes, sir. Sir. Definitely,
Hello.
sir. Definitely, sir.
Okay.
Hello.
And Mr. Sheshagiri has posted
Thank
a
you, sir.
question, sir. He is from Hyderabad.
yes,
He has posted how to find the failure of pile after some time of casting.
It's only one I have.
yeah, failure. That's why we used to do PIT test. After curing, we used to do pile integrity test. Even the last series I showed you how to identify. See, that's why I told pile is nothing like a postmortem. It is already, it is there. You don't know where it went, what is it. That's why we are doing a pile integrity test. Hitting the hammer, transferring the wave, there it will show that whether the pile have a crack or a necking problem, something, the voids, that everything. Then you will be patch upping by doing some other techniques. So that you have to concentrate. Otherwise, in one of the coming presentation, I now I understood you are completely enjoying the foundation part. Now, for especially for you, I will make some foundation testing once presentation. I will try to give you. So whatever you are doing, the foundation, how to cross check that, you will come to know. This
We will have one separate session, sir.
session for that, because that is also different topic.
Yeah.
What you are telling, whatever now you have seen, that is only doing the design in the office. What you are asking the question is practical question. I have done the design, I have done the construction, but how to ensure that? Yes, we have that. Even the code book will say that every 1 kilometer you have to do one pilot test. How you will ensure that? I will be teaching you in the next series. So
Hello.
your doubts will be cleared.
Yeah.
Sir,
Yeah.
I have a question.
Can you
Yes.
introduce yourself and ask the question, please? Thank
My
you.
name is Mrityunjay Swami. So
Okay.
my question is that how many floors can be built upon a wood footing foundation?
Wood footing.
Yeah,
Wood or timber?
the timber wood.
See, again, I told you now what type of construction you are doing. Maybe
Okay,
G
yes,
plus
sir.
1 or
That
G plus 2, you can go.
okay.
See, again, I told you this all depends on the soil condition.
Yeah.
If soil is good to able to take, you can go for G plus 1, G plus 2. If soil
Okay,
is not that much, that is the tricky of shallow foundation.
okay, sir.
That's why to make that, that's why we are making little bit offset. The load should be transferred equally, like 50 centimeter depth should go. Now we are giving that guidelines because whatever the structural load is coming, it should be equally distributed and it should take care that.
Yes, sir.
Yeah, that is the reason.
Okay.
When you're designing, you should fulfill. When you're designing, your foundation size may come or offset size may come less. It means that still you should not. What is the guideline? You have to retain that much mandatory. That will
Okay,
be
sir.
safer for long run, not now.
Okay, sir. Thank you.
Future you may think that you want to do one more floor. Then what you will do? You
Yes,
can't
sir. That
change the
is
foundation, right? Always
yeah.
thinking for a long run. So
Okay,
when you are
sir.
doing, you should be very cautious. Take a little bit factor
Okay,
of safety.
okay,
That's it.
sir.
Okay.
Thank you. Yeah, thank you.
Sir, can you unshare your screen, sir?
Thank you. Okay, sure.
Yeah.
Yes.
Yes, I hope the session was very much informative and a lot of questions and interaction happened. I hope Dr. Naveen also enjoyed today's session. Yes, sir, of course.
Yes, sir, definitely. That's why
Yeah.
I'm
Yeah. And
trying to always try to interact with, especially with.
yes, and there is an outcome also for some questions passed on, and one more session also we are planned for testing on this thing. Foundations, separate session is planned, Mr. Seshagiri, after your questions. Definitely,
That clearly shows that, and we should say thanks to participant, and especially for you, they are giving motivation me to work on new assignment. I'm really enjoying. Initially, I never think that I was planning to give a simple talk, but now the student response, they are coming with their questions. So this question can be addressed only when we start presenting on that question. Like now they are asking particularly on the testing related. If I tell you in one line, their queries won't be clarified. So we have to give some sufficient time, and they should have a enjoy the, like how they have enjoyed the deep foundation, shallow foundation. I'm really thankful they are giving their valuable time, and they are putting their mind and spending time on weekend, especially to understand the technical things. Now they are open upping their mind, and they are asking good questions. Really, thanks for the participation.
yes, Dr. Naveen.
Yes.
There is a very good response from the audience also, and we are very much motivated for that. Thank you for your time. And I request audience, we have shared the feedback form in the message box in the Zoom, as well as we will be posting in the YouTube live also. You can fill the feedback form so that our speaker will get an idea about what you feel, because a lot of audience are attending this session. We can't ask each and every, we can't provide the opportunity to everyone to speak also. So the feedback form makes sense, and your e-certificate also will get generated automatically once you fill the feedback form. Kindly do the same. And for the YouTube, definitely we will be posting the feedback link after the session is getting ended. And for the Zoom people, we have already posted. the feedback form. Definitely your feedback, we are reading your feedback, and based on that only we are working on it on various programs. I thank everyone, the participants, the speaker, and the organizers, and supporting colleges, and everyone for this wonderful session, for making it happening. And this is the 14th session of the infrastructure lecture series. Dr. Naveen sir, the update is we are going to extend this session beyond 16 also, sir, because a lot of new plans are there, and audience response is very good, and infrastructure is doing well. And we thought we will continue this session for another 14 sessions. It will be extended up to 30 sessions, you can say. It will be continued. Yesterday also, while signing the MOU with the Dayanand Sagar College of Engineering, I spoke there, and I told this is definitely helping the students a lot. And we will extend this series, and I request colleges to send more students for this program, and for the people who are there, kindly attend. This is only 1 hour session only every week we are providing. There is no fee for this particular program, this webinar. Make use of it, and the recording also available. Use the technology. That is my sincere request. And we are having many programs available in our website. You can visit, and if you want any fast track course with supporting with the trainers, because trainers definitely, if you have any queries, you can contact them. A lot of interactive sessions are happening with limited number of students, and offline training also is happening in Bangalore. So any of people interested in short-term or long-term programs, you can enroll for that. You can visit our website www.cmta.co.in, and you can speak to our backend team. They will support you. They will give the career guidance nicely as per the requirements. Welcome, sir. Mr. Subhash Pathak has joined now. I think, sir, the program is just over. Thank you for joining. I think he has seen the link now only. Subhash, sir? He is a senior person from Pune, having 55 years of experience. Sir is also going to give some lectures in the forthcoming programs. I think his mic is muted. Sir, your mic is muted. Will you able to speak, or we will have a separate session? I think we will have separate session as the time is up. We will have the separate section. Thank you, sir. Thank you, Dr. Naveen, and the audience for joining in once again. Thank you.
Thank you, Ashok. And I also thank all participants for their valuable time. If you have any queries, feel free to discuss with me. My email is available, or you can contact Dr. Ashok for further discussion. Thank you. Thanks a lot.
Okay, sir. We will sign out.